Hi, so now I'm going to be going over my second question for the Unit 4 assessment. So the question was, given f of x is equal to negative 1/3 x cubed plus b of x, for what values of b would f of x always be decreasing? Justify your answer. So when you're looking at a function, usually the first derivative and also sometimes the second derivative have to do with the looks of the original function. So we know that the first derivative gives us the insight of if a function is increasing or decreasing and where it is when it's increasing or decreasing. So I took the derivative of the function, which ended up giving me f prime of x is equal to negative x squared plus b. So in this case, that means that b is going to be the shift, specifically the vertical shift for the derivative function because it is a parabola. So I knew that because it's a parabola and it's facing down, as we also know because it starts with a negative in front of the a value, that the function for the derivative must have a b value which allows it to stay below the zero axis, always being a negative value. And this is because by it staying negative, that means the original function would always have to be decreasing. So what I did is, since I figured that out, I ended up realizing that f of x will always be decreasing whenever b is anything from negative infinity to 0, including 0. And I checked over my work by plugging in both the first derivative function and the original function into Desmos. And here you can see that I have the b value at 0. And as you can see at 0, that the original function, which is in red, is still decreasing, and the parabola is still in the negative quadrant. Then here you can see that I put it into a very small negative number, which is negative 0.3. And you can see that the red function, which is the original function, is always decreasing, and the parabola is also staying in the negative quadrants. Lastly, here you can see that I put b to be a positive number, even though it's very small, which is 0.3. And you can see that the positive original function has a section which I highlighted here where it's positive. You can see that it's increasing and going up. And you can see that the derivative function is going into the positive quadrants in the smallest bit, going past the zero axis on the going past 0 on the y-axis. So this shows that as soon as the b value goes over 0 in regards to y in the y-axis, that the original function would become increasing in a point, and that the parabola, which is the derivative function, the first derivative function, would go into the positive quadrant. And it's also supported in the other two diagrams which I showed, because just to quickly go over them again, once the b value is a negative, the parabola, which was this first derivative, stayed below the 0 on the y value, and that that the original function, which is the red function, was always decreasing and there was no points where it was increasing. And lastly here, where it is 0, which is included in when the function should be decreasing, that the original function has no points of increasing, and that the derivative function is not passing 0 on the axis, meaning that it will always be negative or 0 being included for f of x to be decreasing constantly.